Here's what we want to do. Here is one function, and here is another function. Suppose I want to find the bound area between these two functions, the y-axis and x equals, let's call it a.
Between them?
Between two functions, this axis and this point. Which is to say I want to find this and this. How do I find the area between two functions?
First function minus the second one.
Why does that work? Explain it. These people haven't got there yet.
Because just the area of the first one minus the y area, which is what's contained by the purple one.
Does that make sense to you? Not really. Why is it to find the area between? He's right, I can subtract the two functions and then find the area. Because one thing to do, obviously, is work out the area under the purple, subtract the area under the green.
Oh, interesting.
On this side, work out the area under the green, subtract the area under the purple. But remember, to find areas, I'm doing integration, some area minus some other area. Right? One area minus another area, but that's exactly the same as doing that. So I can subtract the functions first and then integrate. So
Do you need to know where they intersect?
you absolutely, because that's equivalent to finding the zeros in this function.
Yeah.
Right? You have to work out, do they cross between the bounds I care about? We have to work that out.
Not exact.
Determine the exact bounded area between.
So is that not exact?
No, it's approximate. Calculator can't do exact. Not for that.
Interesting.
Determine the exact bounded area between, what am I doing? F of x equals 1 over 1 plus x squared. And g of x equals half x squared. What a mess. X squared. Didn't specify any bounds, so we're going to have to find them. What does half x squared look like? That's the easy one to draw.
Quadratic with a gradient of 1.
Uh-huh. So it's just going to go, right? G of x.
Use it again, I can't see it.
Is that better?
Mm-hmm.
Okay. Where's the other function? Any of you know what this looks like?
Yeah, the octave.
Reciprocal.
That's the integral, but what's this graph look like?
Reciprocal.
Like this.
Sketch on the calculator.
Little hill.
Yep, little hill. Okay, that means I want this.
Interesting.
Okay, what's this point and this point? What are the x coordinates? How do I solve that? Make the two functions equal to each other. Go, solve for x. Set them equal to each other, solve for x. Quadratic and x squared. Plus 2 one of those I can reject.
-2.
X squared can't be negative. Not possible. But I still have two solutions, one on each side. 1 and -1. Okay with that? Which one is bigger? G of x or f of x?
Bigger in what sense?
In a larger number in the section I care about.
F of x.
F of x. So I'm going to go f of x minus g of x to get a positive number. This one minus that one will give me a positive area. Okay? So I want the integral of f of x minus g of x dx, and I want it from -1 to 1. F of x minus from -1 to 1. Maybe I'll keep writing the way I normally write, so as not to confuse you. Maybe I can go straight to it. You guys know what arctan 1 is?
1.
Good. Minus a sixth minus brackets negative minus a negative, and -1
Positive.
plus a sixth. Too many brackets. Okay, pi, so 2 pi and 4, which is pi on 2, minus a sixth, minus a sixth. No tech required, as long as you can work out how to sketch this. If you couldn't sketch this, you can still work out where they cross. Two solutions.
And do it.
I want the area between. Do the thing. If you got these the wrong way around, you'd get a negative integral. Oh, I had them the wrong way around, swap them over. If I solve for them equal and I get 3 points, do this section and then this section, absolute value of each, add them together. You don't really need to sketch, just sketching helps me to go, oh, I know what I'm looking for and I know which order to put them in. Suppose I have to find the area of this. No, other way around. Suppose I want to find this area in here.
Use y is equal to.
Shh. I think you know what to do. Didn't say it quite right, but I think you know what to do. I'll let these people think. How do I find that area? Anyone want to have a guess before Ben does?
Use y equals something.
He said it wrong. What am I going to do, Ben?
Use a constant.
No,
Like y equals a constant.
no. Oh, you could. There's a quicker way. I see what you're saying. Yes, you could. You could find the area between y equals this constant and this curve. There's a quicker way. Right? Now, find me the area from 0 to whatever this number is, b, of x dy. Just flip the variable. Integral from 0 to b of y squared dy. Just swap variables. Effectively, you're going, let me find this area instead. So you can do it either way, whichever you prefer.